Hi friends, welcome to the lecture of Advanced Discrete Mathematics. Today we are going to study the last chapter of ADM, which is a Combinatorics. Okay. Now, actually, combinatorics is a branch of discrete mathematics and which can be used to find out some counting problems. Combinatorics is actually very important in mathematics, computer science, and especially in the probability theory. And combinatorics is also used in analysis of some algorithm. In the chapter, we will discuss some basic counting problems. That is, we have to study some basic counting methods. That is which are nothing but addition rule, that is the sum rule, product rule, what is a permutation, combination. After that we have to see what is the recurrence relation and generating functions, okay, and their applications. First we will see some fundamental principles. In fundamental principle, the first one is a sum rule. Sum rule. Okay. Now we have to see what is a sum rule. Suppose there are two events, A and B. If if an event can occur in m ways, m ways, and another event, another event can occur in n ways, and these these two events cannot occur simultaneously, cannot occur simultaneously, that is at a time, simultaneously, then one of these then one of the two events two events can occur in m plus n ways. If suppose A and B are two events where event A can be occur in m ways and event B can be occur in n ways, and these two events A and B cannot occur simultaneously, they can be occurring separately. Okay, now the number, then one of these event, that is either A or B, can occur in m plus n ways, then there are possibility for occurring of any event are nothing but m plus n. Since event A can be occur in m ways and event B can be occur in n ways, then there are total number of possibility for occurrence of any event is m plus n. Okay, that is in general, if ei, whenever I running from 1 to up to so on k, are k events are k events such that no two of them no two of them can occurs at same time, occur at same time, and each ei can occur in ni ways, then the then one of the k events can occur in n1 plus n2 plus up to so on plus nk. That is, we have here first seen for only two events. If suppose there are more than two events, that is EIB the number of events, that is whenever I running from 1 to k, then the total number of events are k, and these k events are such that no two of them, that is either e1 e2 or e1 e3, whatever it will be, no two of them can occur at the same time, and each ei can occur in ni ways. Then one of these k events, that is any event from these k events, can occur in n1 plus n2 plus up to so on nk ways. Then any event have n1 plus n2 plus up to so on nk possibilities. Okay, let us see one example. First one, if there are 14 boys and 12 girls in a class, then find the number of ways of selecting one student as a CR, that is as a class representative. Now we have to see what is the use of this sum rule. Okay, if suppose there are 14 boys and 12 girls in any class, then here we have to find out the number of ways of selecting one student as a class representative. That is, one student is either a girl or a boy. Now, in this method, in this problem, we have to use a sum rule. According to sum rule, if suppose any event can occur in n ways and the another event can occur in n ways, and these two events cannot occur simultaneously. That is, here we can't take two students as a class representative. So here we can use the sum rule. Then one of these two events can occur in m plus n ways. Then according to sum rule, 14 plus 12 is equal to 26. So the number of ways of selecting one student as a class representative are nothing but 26. Okay, there are 14 possibilities for boys and 12 possibilities for girls. So there are total 14 plus 12 equal to 26 possibilities to choose one student as a class representative. Similarly, suppose second one. If a student is getting admission in 4 different engineering colleges and 5 different medical colleges. 5 different medical college. Now find the number of ways of choosing one of the above columns. Okay. So here any student A is getting admission in 4 different engineering colleges and 5 different medical colleges. Now we have to find the number of ways of choosing one of the above college. According to some rule, if any event can occur in m ways and the another event can be occur in n ways, then these two events cannot occur simultaneously. Then one of these two events can be occurs in m plus n ways. Here, if we take A as any student, then A can take either a admission in any one of these four different engineering colleges or any one of these five medical colleges. Any student can't take admission in both that is two colleges, that is either which are two engineering colleges or one engineering, another is medical, or two medical colleges. If student is getting admission, then he or she can be take admission in only one colleges. So here we can use a sum rule. So according to sum rule, there are 4 plus 5 equal to 9 ways to choosing one of the above college. Okay, now we have to see what is a product. Now we have to see what is the product rule. If an event can occur in m ways and and second event can occur in n ways, and the number of and the number of ways of second event event occurs does not depend on does not depend on the occurrence of first event. Then these two events can occur simultaneously in m into n. Yes. So here again there are two events. Suppose event one is A and second event is B. If suppose A and B are two events where event A can be occur in m ways and the event B can be occur in n ways, and the number of ways of second event occurs does not depend on the occurrence of the first event, then these two event occurs simultaneously in m into n ways. In some rule, both the events, any two events cannot occur simultaneously. But in product rule, if we take n1 n2 up to so on, sorry, a b c d up to a1 a2 up to so on a k b, any k events, then these k events occur simultaneously in product of this corresponding number of events. Okay, in general, if ei, whenever I running from 1 to k are k events and E1 occurs in n1 ways, E2 occurs in n2 ways. Here for second, no matter how E1 occurs. Okay, E3 can occur E3 occurs in N3 ways. Again, there is no matter how E1 and E2 occurs, and up to so on, EK can occur in NK ways, and again it is independent of the first K minus events. That is, no matter how K minus 1 event occurs. Then these K events, then these K events occur simultaneously in N1 into N2 into so on into Nk. Okay, if ei whenever I running from 1 to k be any k events, and event e1 can be occurs in n1 ways, event e2 can be occur in n2 ways, no matter here how event e1 is occurring. Similarly, E3 occurs in N3 ways, no matter how E1 and E2 occurs, and up to so on, EK can occurs in NK ways, and there is no matter how the first K minus 1 event occurs. Then these K events occur simultaneously in product of these K events. That is number of the product of this K event, that is N1 and 2 and 2 up to so on into NK ways. Now we have to see some examples depending on this product rule. So first, three persons enter into car where there are five seats. There are five seats. In how many ways? In how many ways they can take up their seats? If suppose there are three persons, okay, and these three persons are enter into car, and the number of seats in the car are five. That is, the three persons enter into car where there are five seats. Now here we have to find out the number of ways of taking these three persons can take up their seats. Okay. Now, if suppose first person is enter into car, that is, if suppose A, B, and C are three persons. Okay. Now, if suppose person A is entering into car, then the number of possibilities for person A will be 5, since person A can take any among these 5 seats. That is, person A has 5 possibilities. Similarly, if suppose B is entering into car, already there A is present, then number of possibility for person B are 4. Okay. Now, if lastly, if C is enter into car, already there are A and B are present. Then there the number of possibility for person C are 3. Then the total number of ways of taking their seats by these three persons A, B, C are nothing but the product of these numbers. That is 5 into 4 into 3, which is equal to 60. So, in 60 ways, the three persons can take up their seats. Okay. Now, the second example is there are four roads, from city X to Y and 5 roads from city Y to J. Find first how many different ways, different possible ways to travel from city X to city J via city Y. And second one, so here there are four roads from city X to city Y and 5 roads from city Y to city Z. Then we have to find out how many different possible ways to travel from city X to city Z via city Y. That is in first step we have to find out the number of different possible ways of travel from city X to city Z via city Y, and second step we have to find out how many different round trip routes are possible to travel from city X to city Y, city Y to Z, city Z to Y and back to X. That is X to Y, Y to Z and Z to Y and again Y to X. Okay. Let us see first one. Now, in first step, we have to travel from city X to city Z via city Y. Okay. Now, from city X to city Y, there are 4 roads. If suppose here is 4 X and here is Y, and from city X to city Y, there are 4 routes. If suppose these are the 4 routes from city X to city Y. That is A1, A2, A3 and A4 are 4 routes from city X to city Y, and there are 5 roads from city Y to Z. If suppose here is Z, then there are 5 routes from that is some B1, B2, B3, B4 and B5. Okay. Now there are 4 roads from city X to Y and 5 roads from city Y to Z. Now here we have to find out how many different possible ways to travel from city X to city Z via city Y. That is, we can't travel from city X to city Z directly. That is, there is no here we can't take any other route from X to Z. That is, we have to travel from Y. That is via Y. So now we have to find out if we travel from city X to city Y by this road A1. Okay. Then from this Y there are 5 possibilities. Okay, so we can take one of the b1, b2, b3, b4 or b5 for from y to z. So for a1 there are 5 possibilities. Similarly, if we travel from this road A2, then again for A2 there are 5 possibilities. A2 has 5 possibilities. A3 has again 5 possibilities, and A4 has in 5 possibilities. Then the number of ways of the number of possible ways to travel from city X to Z via city Y is equal to, from the product rule, 4 into 5, which is equal to 20. Since if we travel from road A1, then there are 4 possibilities, then there are 5 possibilities. Similarly for A2, A3 and A4, then the number of possible ways to travel from city X to Z via city Y will be equal to 4 into 5, which is equal to 20 ways. Okay, now we have to find out the second one. The round trip, the round trips can be performed in following 4 ways. Here we have to perform a round trips, that is from city X to Y, Y to Z, Z to Y, and again back to X. Okay, first one is from city X to Y. From city X to Y. Second, from city Y to J. In third one, from city Z to X. And last one, from city Z to Y. From city Y to X, then our round trip will be complete. Okay, now there are 4 possibilities from city X to Y. There, that is the first, this first one A can be performed in 4 ways. Since there are 4 possible roads from city X to Y, which is actually already given, and 5 ways of performing 5 ways of performing this B, since there are 5 roads from city Y to J, performing B. Again, 5 ways of performing Z to Y, that is travel from city Z to Y. As there are 5 roads from Y to Z, then as it is, there are 5 roads from Z to Y also. So 5 ways of performing C, and 4 ways of performing this last one D. Then the number of different round trips is equal to the number of different round trips is equal to 4 into 5 into 5 into 4, and 4 into 5, 20 into 5, 100 into 4, 400. So there are 400 ways. Okay. Similarly, we can use the product rule for such type of examples. Okay. Now we have to see the next point, which is the factorial innovation. Real notation. The product of n consecutive positive integers starting from 1 is denoted by this symbol or this one, and read as factorial n. If suppose there is a number n, then the product of n consecutive positive integers starting from number 1 is denoted by these two symbols, either this symbol or this one, and it can be read as factorial n. If suppose n is given, then the product of n consecutive integers starting from 1, that is 1 into 2 into 3 into up to so on into n minus 1 into 1 is nothing but the factorial n, and this can be also written as n into n minus 1 into n minus 2 into up to so on 3 into 2 into 1. Okay, and which is nothing but n minus 1 into n minus 2 into up to so on 3 to 1, that is the product of n minus 1 consecutive integers starting from 1 is nothing but n minus 1 factorial, that is this can be written as n into n minus 1 factorial also. Okay, now suppose if r and n are positive integers such that this r is less than n, then n factorial upon r factorial is equal to n factorial is nothing but n into n minus 1 into n minus 2 into up to so on. Here r is less than n, then here somewhere is r plus 1 into r up to so on 3 into 2 into 1, and which is divided by r factorial, and which is nothing but r into r minus 1 r minus 2 up to so on 3 into 3 into 1. So from here all the terms are same, then they are cancelled, so which is nothing but n into n minus 1 into n minus 2 into up to so on r plus. Similarly, n factorial upon n minus r factorial. Here also r is less than n. N factorial is nothing but n into n minus 1, n minus 2 up to so on. Somewhere is n minus r minus 1, n minus r, n minus r plus 1, and up to so on 3 into 2 into 1 divided by n minus r factorial, n minus r plus 1 up to so on 3 into 2 into 1. Again, these terms from this n minus r to this again in numerator and denominator, these terms are common, so these terms are cancelled. From here all these terms are cancelled, so which is nothing but n into n minus 1 into n minus 2 to so on n minus r minus 1, which is nothing but n minus r plus 1. Okay, for example, let us see 5 factorial upon 2 factorial, which is equal to 5 into 4 into 3 into 2 into 1, which is divisible by 2 factorial. 2 into 1, 2 into cancel. 5 into 4, 20, 20 into 3, 60. Similarly, second one, 3 factorial divided by 6 factorial. This can be written as 3 factorial divided by 5 into 4 into 3 factorial. Sorry, 6 into 5 into 4 into 3 factorial. 3 factorial, 3 factorial will cancel. 1 upon 6 into 5 into 4, which is equal to 6 into 5, 30. 30 into 4, 3 into 4, 12, 120. 1 upon. Okay? Now, prove that 2n factorial is equal to 2 raised to n into n factorial into 2n minus 1, 2n minus 3, up to so on 3 into. Okay? Consider 2n factorial, which is equal to n factorial is nothing but the product of n consecutive positive integers starting from 1. Therefore, 2n factorial is nothing but 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 and up to so on 6 into 5 into 4 into 3 into 2 into 1. Now collect the all even terms in one bracket and all the odd terms in another bracket. So here we get 2n, 2n minus 2, 2n minus 4 and up to so on 4 into 2. And in second bracket 2n minus 1, 2n minus 3 and up to so on 5 3 1, 5 into 3 into. Okay, now taking 2 common from the first bracket, then we get 2. From this one we get 2. Again from this one we get 2. Then here we get n. First here if we take 2 common, then here we get n minus 1. If we take 2 common again, then here we get n minus 2. Up to so on. If from this 2, if 2 is common, then it is 2, and if from this one if we take 2 common, then it is 1. And the number of 2's common between the all the terms, first one, second, third, up to so on, there are n. How many 2's are possible to take common? There are n, since from from this n1, n minus 1, in n minus 1, second one, from n minus 2, third one, up to so on, there are n 2's can take the common from this even terms. So it is nothing but 2 raised to n into n minus 1, n minus 2 up to so on 2 into 1. And second one is as it is, that is 1 into 3 into 5 into up to so on 2n minus 3 into 2n minus 1, which is equal to 2 to the power n. N into n minus 1 into n minus 2 into up to so on 2 into 1. That is the product of n consecutive integers starting from 1 is nothing but factorial n. Which is nothing but factorial n. And this one is 1 into 3 into 5 into up to so on 2n minus. And here is the required result. Here is the. Okay. Thank you for watching the lecture.